Today we're going to be using the gas law equation P1 V1 over T1 equals P2 V2 over T2. But what we're going to be seeing is that our pressure units are not going to be the same. So what we're going to have to do is make sure that they're the same on each side so that the pressure units match. So we're going to be using this conversion to convert one of the pressure units so that they match. So let me show you what I'm talking about. So let's say we have a word problem like this. And I see that, oh, I've got 18 liters at a pressure of 938 torr. And I've got some new volume that I don't know. I want to find it, right? What is the new volume? But my second pressure is 700 kPa. Well, I'm noticing, my pressure units, one is torr and one is kPa. Those don't match. And so in order to solve this problem, I need them to match. So what I'm going to do is I'm going to look at the pressure unit conversions. It's 1 ATM equals 760 torr equals 760 mmHg equals 101 kPa, and I'm going to choose what I want to convert to. So either I can convert the kPa right here to torr, so that both my numbers are in torr, or I can convert the torr right here to kPa so that both my numbers are in kPa. So what I'm going to do is I'm going to look down here and I'm going to say, well, this number is really big and this number is much smaller. 101 kPa is smaller. So what I'm going to do is I'm just going to choose to convert and have both of my pressures in kPa. So I'm going to choose to convert to kPa. It doesn't matter which one you choose. It's just, I'm just choosing kPa because I want smaller numbers. So I'm going to say, well, I want my 983 torr. I want that to be kPa. So I'm going to say equals what kPa. And then I'm going to use my conversion. Well, it says 760 torr is equal to 101 kPa. So I'm going to make this a fraction. And you're going to do this for every single one. And then I'm going to put 760 torr. And I'm going to put 101 kPa. This is my x, right? And then all I'm going to do is cross multiply and solve for x. So when I cross multiply and solve for x, what I'm going to get is, I'm going to get that 983 torr is equal to 130.64 kPa. All right. So now I know that I've got 130.64 kPa for that one. It's no longer 983 torr, and my second pressure is 700 kPa. So what I'm going to do is I'm going to set up my problem. So I know I have an elastic container. It's inflated to a volume of 18 liters at a pressure of 983 torr, right? 983 torr, but we changed that to kPa, so the new number is 130.64 kPa. So no longer am I using that. Okay, V2 is X. We wanted to know what the new volume is going to be, and my second pressure is 700 kPa. So now I see that both of my pressures are the same units. That's good. That's what I want. And I don't have any temperatures, so I don't have to worry about temperature in this equation, right? So let's see. We're going to solve, and the way to solve is P1, which is 130.64, P1 V1, which is 18, equals P2, 700, V2, X. And so when you solve for x, you should get 3.359 liters, which rounds, if I want a hundredths place, to 3.36 liters. And so that's how I got the 3.36 liters that you see on your handout. Okay, let's look at another one. Let's say we have to calculate the volume of a gas at STP. Remember, STP is standard temperature and pressure. Oops. So standard temperature and pressure. Standard temperature is 273 Kelvin. Standard pressure is 1 atm. So here I'm going to use P1, V1, T1, P2, V2, T2. I don't know if I'm going to have all of these variables, but we'll see what we have here in this word problem. So it says calculate the volume of a gas at STP if 490 centimeters of the gas are collected at 476 Kelvin and 96 kPa. So we know we've got 490 centimeters at 476 Kelvin and 96 kPa. So I can plug all those in for my P1, V1, T1. So 490 centimeters cubed is volume. So 490 centimeters cubed. And that's at 476 Kelvin, so that's temperature, 476 Kelvin, and that's at a pressure of 96 kPa, 96 kPa. So we have to calculate the volume, so that means V2 is going to be X, at standard temperature and pressure. So standard temperature is 273 Kelvin, and standard pressure is 1 atm. Okay, so it looks like we have every single one of these variables except for V2, so we're going to go ahead and solve for V2. But before we do that, we have to check that all of our units are the same, and they're not. For P2 we have 1 atm, but for P1 it's in kPas. So now again we have to decide, do I want to convert everything into ATMs or do I want to convert everything into kPas? Well, if I look at that whole thing on your first slide, look at your first slide of your notes. It says 1 ATM equals 760 torr equals 760 mmHg equals 101 kPa. I'm always going to use the units of the smallest number. So I have a choice about between kPas or ATMs. If you look at your handout, what number is smaller in the equality there that you see on slide 1? Is it ATMs or is it kPa? The answer is ATMs. ATMs are only 1, but on that equality, kPas are 101. So I'm going to convert everything to ATMs. So P2 is already an ATM. I'm going to convert P1 to ATMs, atmospheres. So what I have is right now I have 96 kPa. I want to convert that to ATMs so that my units are the same. So equals how many ATMs? That's my question. And I'm going to go ahead and plug in my equality that's on that slide 1 of your handout. And it says 1 ATM is equal to, right, 101 kPa. If you look at the handout, first slide, it says that. All those equal signs, those are all equal to each other. So you can use any one. They're all the same. So we're going to go ahead and cross multiply here and solve for x, right? And you all know how to do that, and we're going to get our answer as 0.95 ATM. So I'm going to take that and I'm going to plug it in here. So instead of 96 kPa, it's going to be 0.95 ATM. So now I've got all my numbers in ATM for pressure. So now I can go ahead and solve. P1 is now 0.95. V1 is 490 centimeters. Well, don't worry about centimeters. Let's just use numbers and forget about the units right now. Over T1, which is 476, equals P2, 1 V2 is x over T2 is 273. Cross multiply, solve for x, and what you should get is 267.12, and x was volume, and our volume is centimeters cubed. Okay, so that's what you see the answer is there on slide 3 in bold. So this is how you're going to do these. Go ahead and give it a try. You've got, looks like 10 problems to do. And this video is going to be up on YouTube, so if you need to watch it again, you know where to look. Look in School Loop.